At the systems problems on the back of the equations and inequalities packet from last time. From packet number 2. So anytime that you guys have a system of equations, easiest thing to do, solve it for y and graph it, okay? So if I look at this first one, y plus 2x equals 2, well, if I solve that for y, no, you know what? I'm gonna put this on a separate slide. There we go. And we'll solve it from here, okay? So the first one, y plus 2x equals 2. If I were to make this y equals, what do I have to do?
Get rid of the f.
Yeah. So let's move it. Move that 2x. Subtract it over to the other side. So then now I have y equals negative 2x plus 2. Right? This becomes y equals negative 2x plus 2. Yes? So then let's look at the second one. I'm going to solve it for y. What should I do first?
Move the x squared.
Move the x squared. And I have 3y equals negative x squared plus 22.
And take the square root.
You're solving for y. Divide by 3. Here's the thing though, when you guys put it into the calculator, you just put that whole thing, over 3. Put that in parentheses on top, right? So when you put this into the calculator, you can just say y equals, parentheses, negative x squared plus 22 divided by 3. See that? You have those written down? Let's put it into the calculator. That one goes into y sub 1. This one goes into y sub 2. All right, let's do it. Just like this, right? Okay. So put it into the calculator just like this. Thank you, Tom.
So what, do you click enter after it or graph?
Yep, and so let's graph it. So we're going to hit graph. Oh no, did I put it in wrong?
Oh no, I got the same thing.
Uh-oh, hold on. Did I put the other one? Hold on, let me see. Negative 2x plus 2. Oh, I didn't put negative 2x. Oh no. 2x. Oh no. Oh my goodness, what is happening? Hold on. There we go. Negative 2x plus 2. Oh, sorry, I put negative x squared, didn't I? Why do you guys help me? Alright. Now it should look like this.
Yeah.
Yeah. So when you have a system of equations, where are the solutions? Where they do what?
Where it connects,
No, not touches the x-axis.
Where it intersects.
Where they intersect. Where they touch each other, basically, right?
Yeah.
So there's one there. Looks like there's another one, but it goes off our screen.
But can't you zoom out?
Yeah, let's zoom out. So I'm going to go to zoom. I'm going to go to zoom out and hit enter, enter again. Okay? So now, here's how we get the intersection. Second trace, intersect. Move your blinking bob close to, but not right on the intersection. One of them, okay? So this one, really close to that. Up at the top. Hit enter, enter, enter. What do we get? Negative 2.6. Yeah. Do the same thing with the other one. second trace intersect. I'm going to move my blinking bob close to the other one, not right on it. Hit enter, enter, enter. 8, negative 14. So, which one is that then? A, B, C, or D? Yep. Alright. So look at the next one. Which set of ordered pairs is a solution to the system of equations? Guys, number 2, they're both already solved for y. Put them both into the calculator and find the intersection. Alright. I put in my 2 equations into my y equals. Graph it. It's still zoomed out, but that's okay. It's okay. It's okay. They have this right here. Alright? So it looks like we have those 2 intersections. If you want to go back to the normal, just hit zoom 6. Goes back to the standard. Alright, then I can see it better here. Right?
It's a lot different.
Yours looks different?
Yeah.
Uh-oh. Go back to your y equals. Make sure it looks like mine.
Yeah, it does.
Does?
Yeah. Oh, it's not.
Negative. Mm-hmm. Alright. So then, second trace intersect. I want you to see something here. For the x, you get a little e there, right? Anytime you see an e when you do this with blinking bob, it means 0. Okay? See how there's an e?
Yeah.
0. So this one, 0, negative 1. What's the other one going to be?
3, 2.
Yeah, because 6 negative, 623 doesn't make sense.
That's B.
Yeah. Okay. How about number 3? So number 3, you want to make them both equal to y, but they both have 2. There's 2y, right? So what I can do is I can divide everything by 2. So then all that, divide by 2. Divide by 2, so all that, divide by 2. Right? Since I'm putting it into the calculator, I don't need to worry about simplifying fractions and all that stuff. Just put it in parentheses. So we have y1 equals parentheses x squared minus 6x minus 9 divided by 2. And then I have y sub 2 equals negative x squared plus 2x plus 1 divided by 2. Put both of those into your calculator with the parentheses and everything. Tell me what you get. The intersection.
Got
What'd you get?
0 minus 1 and 3, 2.
What?
2. A.
A? Yeah, A? A? Alright. Good. So let's look at 4 and 5. Alright. 4, you have which is most likely the solution set for the system of equations. When they give you, oh my goodness, when they give you a graph, oh no. When they give you a graph, what you have to do is you have to look at the intersections and figure out what the solutions are. So, right here and right here.
So is that A?
Yeah, unfortunately, I guess it was supposed to be a negative 3 too. Best match would be A, right? Oh my goodness, what is happening?
Probably was getting passed out or something.
Oh no, it's on the back of the one before. Oh no. Okay. So this one, right? What is most likely the solution? Where do they intersect? With a point?
Oh.
That one was like approximate, but that one's good.
Negative 3.
Negative 3, 2. Which one of those has negative 3, 2? Good. 6. Alright, do you guys have any questions on this? Let's go to our functions packet. All right? And let's get started on this. This was fun. All right, so number one, this graph below is an example of which type of function? Absolute value. You see how it's a sharp B, Tom?
Yeah.
Yeah? B for value. Okay? Absolute value. Great. Next. Which most likely represents the equation of this graph? Guys, if they give you the graph and they give you multiple choice, what could you do? Couldn't you just plug in each of these and see which one matches your graph?
Yeah.
Yeah? All right, which one matches it? You gotta think, there's a negative in the front.
Is a negative gonna be below?
Yeah, it flips, right?
Yeah.
So it's gotta be either B or C. Which one is it? B or C? B. All right. Next one. Which of the following is most likely the equation graph? Again, they gave you the graph. Plug it in. Just said it to you. C? All right. Next one. Which sketch would represent the graph of this function? So with this one, isn't it kind of weird because it says f of x equals absolute value of x minus a. Guys, which one of those looks like an absolute value? B. B for value, right? Yeah, so it doesn't matter that they didn't give us a number. Okay, it's still absolute value. All right, so let's look at the next one. This is a portion of the graph of a polynomial function. All right, so they're saying here, basically if you write this in standard form, what could be the first term? All right, this is when we talked about polynomials, I think in unit 5, right? 4 or 5. So guys, how many terms do you see on this graph? How many times does this graph turn? 4. Here's 1, 2, and 3, right? It turns 3 times. Well, if it turns 3 times, your degree or the biggest exponent is always 1 more than your terms. Yeah, so it's 4. That means this is x to the 4th, right?
Yeah.
The next thing that you need to look for is, well then, is there a negative or is there a positive, right? That, you have to look at your right arm, the right end behavior.
You're going up, so it's positive.
Good. It's going up, so it's positive. So this is going to be C. And all of your answer choices, they're all positive. So that should tell you something too. Over here this way. I know it's so exciting, but you gotta try. Alright? Alright, so let's look at the next one. Which could be the graph of this? Ax to the 3rd. Guys, your biggest exponent is what? 3. Has that 2 terms. So let's see, 2 terms. Oh, does this one even have any terms? No, that's out. This one only has 1 term. That's out. This one has 2 terms. This one has 1, 2, 3 terms. That one's out. Yeah? So this one works because it has 2 terms. But I'm going to tell you something else, okay? You know how it says a is less than 0? Yeah? That means your beginning number is a negative number, right? Dylan, look. So, since your beginning number is a negative, look at that right arm. Where's it going?
Down.
Down. Okay, so that's something else I want you guys to keep in mind. Change. All right. So this is a portion of the graph of a polynomial function. Where is a turning point on this function? Huh? Where does it turn? So there's a turn here and a turn there. You said B. Negative 1, 3. Negative 1, 1, 2, 3. Good. That one works. Yeah? Negative 1, negative 2. No. 0, 1. No. 1/4, 0. No. Right? All right, which describes the end behavior of the function as x approaches infinity? Guys, x approaches infinity. Which arm are we talking about? Left or right?
You talking about right?
Right, good. If you're on the x-axis and you're going towards infinity, it's talking about the right, yeah? So what you can do, you have some options here. You can put this whole thing into your calculator and look at what the right arm is doing, right? Or, remember what we said before? What is that beginning number in the front? Is it positive or negative?
Positive.
Positive. So that means your right arm is going how? Up or down? Up. So y approaches what? Infinity. Okay, so you could do it that way too. Alright? Alright. So here is a portion of this graph of a polynomial. They want to know what the domain is. Okay? Guys, this graph has an arrow on the left and an arrow on the right. What is the domain for this?
Infinity.
Negative infinity?
All real numbers.
All the way to infinity? Yeah?
Yeah.
Alright, so all real numbers, A, great. Alright? Listen, the fire truck, like, you know, the firefighters in there, they were looking inside, they were looking at what you guys are learning. Alright, so this is a portion of the graph of a polynomial function, again. So this function has the following types of roots. Guys, what are the solutions here?
There's 3 terms.
Okay, so look at that. Those are all the x-intercepts, right?
4 different real roots.
2 is right. You have 3 terms. 1, 2, and 3, right? If you have 3 terms, that means this whole thing is what? X to the what power?
4.
4th power. Remember? 4, this tells you how many solutions you should have. It's going to be the same, right?
Yeah.
So you should have 4 solutions. Look at how many x-intercepts do you have?
4.
4. If it touches the x-axis, is it real or imaginary?
Real.
Real. So which one is it?
4 different real roots.
Yes. Okay. Good. Is it like a lot easier? Do you guys remember all this stuff? You remember learning all this, don't you?
Yeah.
Yeah.
Second cool.
Yeah. Which value is not a 0 of this? Guys, the easiest way. What can you do? P of x is the same as saying y equals. What can you do with this?
Put in the graph.
Graph it, yeah. Graph it and see which of them is not a 0 or not an x-intercept. Do it, please. What is it? Which one is not? C?
Yeah.
Is it C? Yeah? C is the only one that is not? Yep. Good. Questions about this? All right, let's look at this one. This is a portion of a polynomial function. So apparently this function has a double 0 or a double root at what number? You remember what, or between what number?
I have to plug this one in, or we can just look at it.
No, because they already gave it to you. But this is what they want to know. They want to know if you know what a double root looks like. What does a double root look like? Is it this one? Is it this one? Yeah. Remember, if your graph doesn't go through the x-axis, but it just bounces off, that's a double root.
Yeah.
Okay? So they're asking you, The double zero or the double root is between what two numbers?
1 and 2.
1 and 2. So this one is C. Right? Okay. So this polynomial function has a 0 between what and what? Plug it in the calculator, right? And take a look at where it's between. Let's do that. Let's plug it into the calculator. X cubed minus 3x squared. Alright, so it has a 0 between something and something. Right? That's over here. Okay. So look, you do have a 0 between what? What two numbers? -1 and 0? Right?
Yeah.
Looks like -1 to 0. Because there's one right there. And there's one right there. Looks like it's at 1 though, right? How about this one? Between what and what? This last one, the one furthest over to the right.
Between like 1 and 2.
No, 2 and 3, right? Because there's 1, 2.
Oh
Yeah. But which one of those works? A, B, C, or D? Is there a between 2 and 3? No. Is there a between -1 to 0?
Well, yeah.
Yeah. C, right?
Yeah.
So that one's the one. They're asking you, like, where's the 0 between? So number 8, if the domain of this function, f of x, is limited to that, what is the range? Do you understand what this question is asking you? Yeah? So, if you don't, look, they're just saying you have, no, you know what? I'm not even going to write it as f of x. I'm going to say y. Y equals 2x squared minus 3, right? If the domain is -3, -1, 1, and 3, what is the range? Well, domain is which values?
X values.
X values. And the y is what values?
Y.
Y, oh my god, I gave you the answer, didn't I? The range is y values, right? You could literally put this into the calculator and then go to your x. When you're at -3, what is the y number? When you're at -1, or +1, or +3, what are the y numbers? That's what they're asking. And tell me what you get. Good. You should have C. Because I think it's like negative, is it -1?
It's -3 and 15.
Oh, sorry. 15, -1, -1, and 15.
Yeah.
Okay. All right, let's look at the next one. If f of x equals x squared minus 2x and g of x equals x minus 3, they want to know which one is g of f of x. All right, so g of f of x, yes? Guys, what is f of x?
Y equals
Yeah, but what is your f of x out of the things that they gave you here?
X squared minus 2X.
X squared minus 2x. So instead of that, I'm actually going to write out x squared minus 2x, right? And so now what you're doing is you're going to plug in x squared minus 2x in for the x in your g function. So what is your g function?
X minus 3.
So x minus 3. What goes in for the x?
2X.
X squared minus 2x.
Yeah.
Yeah? Can you combine anything? No. So this is just x squared minus 2x minus 3, which is D. Yes? All right, look at number 10. You guys know how to do these. If they give you f of x, and they said, what is f of negative 3? You could either plug it in, we could store it, or you could graph this guy. That negative 3 is an x. You can go to the table, go to x equals negative 3, and see what the y number is. Whichever way you want to do it. You want to store it, you want to use a table, tell me what you get. Perfect. Number 10 is C, 38. Number 11. So they're asking you about the inverse, right? You guys remember when we talked about inverse? If they want you to give the inverse of f of x equals x plus 2, remember, I said f of x is the same as saying y, right? So if you have y equals x plus 2, what do you do when you're finding the inverse? You need to switch what?
The inverse?
For the inverse. How do you find the inverse? You have to switch something and something. No. You need to switch your x and your y, right? So then this becomes x equals y plus 2. But do I leave it as x equals? No. You need to solve this now for your new y equals. So minus the 2, x minus 2 equals the inverse. Yeah? So what is it? A, B, C, or D?
Okay.
A. Okay. Okay. All right, so the graph of a polynomial function is here. They give you the graph. They want you to give the increasing intervals of this function, okay? So you guys are actually really good at finding the increasing and decreasing intervals, right? What do we need to do? We need to draw a vertical line anywhere that there is a turn, right? Or change in direction. Okay, so there's one there, and there's one here. What numbers, what x numbers do these lines cross through?
Across to
What x number?
E, negative 1.
Negative 1,
And 1.
m1. And you have an arrow on the left, so where's that going?
Negative infinity.
Good. And you have an arrow on the right?
Infinity.
Good. These are your intervals. Now you need to tell me what they're doing in between these numbers. What is it doing from negative infinity to negative 1?
It's going up.
It's going up, so it's increasing.
Yeah.
What's it doing from negative 1 to 1?
Decreasing.
Okay, so we don't want that, right? Because they only wanted the increasing.
Yeah.
What's it doing from 1 to infinity?
Increasing.
Increasing. So which one of those tells me between negative infinity to negative 1?
Negative infinity to infinity. Or
Is that negative infinity to negative 1?
no.
No. How about this one?
Yeah.
Yes. What's the other increasing?
The one below it.
1 to infinity, right? All right, that's not it. That's not it. Okay? This is going to be one on the SOLs where you may just have to like click and highlight it.
Yeah.
Or you may have to like drag it. I think this one is definitely a you just click and highlight though.
Yeah.
If you want to unhighlight it,
Just click it.
click it again. Good.
There's ones where like you have to like draw a little graph to like plot
So
points.
you never have to graph. They may ask you to click on the x-intercepts. And so you just take your cursor, you go to it, and you just click on it. Okay? All right, how about this? Which is a 0 of this? Graph it. Find the x-intercepts, right? Number 2, you know how to do these. Try these. Okay, so which is a 0 of this? Which is an x-intercept?
-3.
-3, good. Look at number 2. A polynomial function has a 0 at x equals -4. Guys, what is the factor? If you rewrite this as a factor, what is it? Yeah, x plus 4. Which of the following functions has x-intercepts of -2 and 1? Which one of those gives you zeros at -2 and 1? Yup. And then which of the following sets contains all the apparent zeros for the function shown? You should be able to do 3 and 4.
Yeah.
B?
Yeah.
All right, how about number 4? Where are the apparent zeros? Guys, remember, zeros is the same as x-intercept, right? Where are they? -2, -1, 1. Yup. If they ask you for the apparent zeros, they're saying which ones are the ones that you can see, right? That are clearly there. All right, so this one is a lot of words. What they're basically saying is, what are the factors of this graph, right? So go and get your zeros first and then rewrite them as factors. So you have this guy, and this guy. It's the same thing, right? X equals -2, x equals -1, and x equals 1. How do you turn x equals -2 into a factor?
X plus 2.
X plus 2. How about x equals -1? X plus 1. How about x minus 1? So see? Yeah. Questions? All right. How about this one? Which of the following sets contains all the apparent zeros for this function? Label your zero. What is it? You have one at -1,
-1 and 2.
and 2, and 1.
And 0.
Good. And actually, the one at 0 is a special one, isn't it?
Yeah.
What is that called again?
Origin.
Well, 0, 0 is the origin, but no, it bounces off. So that's a
Yeah,
double root, right? So, what is it? -1, 0, 2?
C.
C. Yeah. Just because it's a double root doesn't mean we write it twice. You don't write it twice. But this tells me that this is a x to the 4th function because we have 4 roots. Yeah? Alright, so let's look at the next part here. So if you look at number 1, you see this thing? So I'm going to cover this during like Stinger. I think we should look at more of these during Stinger.
We have singing tomorrow?
We do. It's Stingers 1 and 3 tomorrow, okay? So if you look at this, this is basically getting all of the numbers and adding them all up. I'm going to show you calculator steps for this, okay? This sigma right here, sigma means sum, all right? So here's what we do. Go to your calculator. And you're going to go to second stat. Second stat. And then you're going to tab over to math. Yeah? And you're going to do sum because it's sigma. All right? So sum. Now, oops, sorry. And then next you're going to put in this sequence here. So we're going to go back to second stat. You're going to tab over to ops. You see sequence? Fifth one? All right, so now you have sequence. Okay? So my calculator looks like this because it's TI-84 plus. Yeah? If yours doesn't, that's okay. It still follows the same order. After you put the sum and sequence in, now they want the formula. Okay? So put in the formula. 3 minus 2x. I'll write it here too. 3 minus 2x. Put comma. And then you're going to put the variable right here, that guy. So x. And then comma. Yours looks like mine, you just have the x there, right? And then the starting number, the smaller number, okay? 0, comma. And then the bigger number, 4. And that's it. That's all of it. You put all of this in. How many parentheses did you open in the beginning? 2, so you have to close, close. Close 2. If you open 2, you gotta close 2. And if yours looks like mine, just go to paste and it'll plug it all in for you. So it should look like this. Yeah? Close, close. Hit enter. Get -5.
Sum C 3 minus 2 and N 0 4.
Okay, did you hit enter? Good. So -5. Alright, when you get those with sigma sigma written like this, it's called summation notation. It's just a different way to write it. Put it in the calculator. Okay? Alright, so this one. 2 geometric means between 2 and 54. Alright? I think you guys are gonna like this one. Okay, look. Geometric, right? That means you multiply r from number to number to number, right? So they said 2 of them between 2 and 54. We need to find those. Yeah? Geometric means we multiply. Multiply r here, and multiply r here. Do you agree? Since they're multiplying, well, when I go from the back, let's see, 54, you have to divide. Since you're going backwards, you gotta divide, right? What's 54 divided by 2? 27. What's r times r times r? R to the what? Good. Well, so look, 27 equals r cubed, right? Because I had r times r times r. How do you solve for that r?
For square root?
Well, cube root, right? Because it's the cube. Yeah, cube root. What's the cube root here? It's the cube root of 27. 3. That means your r is 3. So that means instead of times r times r times r, well, now we know it's just times 3 times 3 times 3. Does that make sense?
Yeah.
What's 2 times 3?
6.
6. What's 6 times 3?
18.
So what is your answer? What are the two numbers between 2 and 54? C. Okay? Pretty good, right? Isn't that one fun? It's like a puzzle. So look at number 3. If a sub n equals 2 to the n minus 1, which number represents a sub 4? Well, look, you have a sub n equals 2 to the n minus 1, then a sub 4 equals 2 to the what? Isn't this n that 4?
To the fourth.
Yeah, that n, so 2 to the 4, what? 4
Minus 1.
minus 1, which is really 2 to the what? What's 4 minus 1?
3.
3. What's 2 cubed?
It's like a decimal, right?
No, not the cube root, but 2 times 2 times 2. 8. All right? So the number 4, what are 2 arithmetic means? Oh, arithmetic. So for arithmetic, you have to add the common difference, d, each time, right? So between 3 and 24, you have 2 numbers. So 3, 1, 2, and 24, right? We're going to do the same thing that we did, except instead of multiplying r, we're adding d. You agree? Okay. So if we're adding, then what do we do backwards this way?
Subtract.
Good. So do that. Do 24 minus 3. What do you get?
21.
21. All right. What happened here? What's d plus d plus d? Yeah. How many?
3.
Yeah, 3d. So 3d equals 21. Right? You see what I'm doing?
Yeah.
Yeah, so d equals 7, because you gotta divide, right? So if d equals 7, well then instead of plus d, you're saying plus 7. 7, 7, 7. So what's 3 plus 7?
10.
10. And what's 10 plus 7?
17.
And let's double check. 17 plus 7, is that 24? Yes. So this one is the, yeah? All right. So practice putting in this one, okay? So again, I have sigma summation notation. So I have to do sum, that's the sigma part, sequence. What's the formula here? Huh? What's the formula? The one on the right. 2 to the what? X, n or x because you have to put x in your calculator, comma. Now you got to put in everything, right? Then you have the n, which is x, comma. What's the smaller number?
20.
Huh? 1, comma. What's the bigger number? 6, and then close, close. Put that in your calculator. Tell me what you get. Remember, math. No, sorry, it's list math. This one is the ops, right? So second stat. If you put this into the calculator, right? Second stat, go to math, sum. Second stat, go to ops, sequence. Then I have 2 to the x, right? Comma, x, comma, 1, comma, 6. Just like that, right? Close parentheses again. What did you get?